These examples go with Part 2 of Lesson 6.1, Applications of a Normal Distribution. Example 1. Our normal distribution has mean mu equal to 15 and a standard deviation sigma equal to 4. Find and interpret the z-score for x is equal to 11. Our z-score formula is going to be x minus mu divided by sigma. And what we're doing is we're taking an actual point from our data and we're converting it into a z-score so that we can graph it on the normal distribution curve and we can use our table A2. All right, let's fill in our parts. X, they tell us, is 11. Mu, they told us, is 15. Sigma, they told us, is 4. 11 minus 15, that's going to give us negative 4. And negative 4 divided by negative 4 is by positive 4 is going to give me negative 1. So the z-score is negative 1. And what this tells me is that 11 falls 1 standard deviation to the left, because it's negative, of the mean. Example 2. A normal distribution has a mean mu equal to 60 and a standard deviation sigma equal to 20. Find and interpret the z-score for x equals 75. Z is going to be equal to our data point 75 minus the mean, which they told us is 60, divided by the standard deviation, which they told us is 20. 75 minus 60 is 15, and 15 divided by 20 is 0.75. And what this tells me is that 75 falls 0.75 standard deviations to the right, because it's positive, of the mean, which in our case is 60. Example 3. Compact fluorescent bulbs are more energy efficient than incandescent bulbs, but they take longer to reach full brightness. The time that it takes for a compact fluorescent bulb to reach its full brightness is normally distributed with a mean 29.8 seconds and standard deviation 4.5 seconds. A randomly selected bulb takes 28 seconds to reach full brightness. Find and interpret the z-score for x equals 28. All right, what do we know? Let's see, the time it takes for the bulb to reach its full brightness is normally distributed. So the mean, they're telling me that mu in this case is going to be equal to 29.8. Right, and the standard deviation is 4.5, so that's going to be our sigma. And they're telling me right here to use x equal to 28. The z-score will be our data point 28 minus the mean 29.8 divided by the standard deviation 4.5 28 minus 29.8 is negative 1.8. And when we put this into our handy dandy calculator, I believe we're going to get negative 0.40. And what this tells me is that 28, in this case 28 seconds, is 0.4 standard deviations. Less than the mean of 29.8 seconds. Example 4. A normal population has mean mu equal to 3 and standard deviation sigma equal to 1. Find the proportion of the population that is less than 1. This is asking me to find the area under the curve. All right, we've got mu equal to 3, sigma equal to 1, and now that means that this one is actually going to be equal to x. In order to use our normal curve here, we're going to have to convert all this over to a z-score. So we're going to take our data point 1, subtract our mean 3, and divide it by the standard deviation 1. 1 minus 3 is negative 2, and negative 2 divided by negative 1 is going to give us negative 2. And so here's negative 2, conveniently already located on my curve, and we want less, so we want the area over here to the left of negative 2. And all I need to do is go over to table A2 and find negative 2.00, and it should tell me what the area is right here. So let's bring up table A2. And we wanted the negatives, so that's going to be up here. Negative 2.00 right here. So 0.0228. So the proportion of the population less than 1 is 0.0228, which is a little bit more than 2%. Example 5. A normal population has mean mu equal to 40 and a standard deviation sigma equal to 10. Find the probability that a randomly sampled value is greater than 53. Once again, we're supposed to find the area underneath the curve because it's asking for a probability. And once again, I'm going to need to take my information over here and turn it into a z-score so that I can put it on my normal curve. Now mu they've given to me, sigma has been given to me, and this 53 will be my data point x. Our z-score will be equal to our data point 53 minus the mean of 40 divided by the standard deviation of 10. 53 minus 40, that's 13, and 13 divided by 10 is 1.3. Now we take the 1.3 and we figure out where it's located down here on the horizontal scale. 1.3 is a little bit more than 1, so I'm going to put it a little bit past 1 right here. I'm going to call this 1.3. And then I'm going to draw my vertical line up so that it touches the curve there. Now the area that we're looking for is supposed to be greater than this z-score, and so I want to know about all of these back here. I'm going to use table A2 to help me with this, but when I do and look up the 1.3, it's going to give me this area over here. And remember, my answer is going to be the purple area over here. So what I'm going to have to do is use my rule of complements. Once I know the white area, I'm going to subtract it from 1, and it'll tell me what's over here in the pink area. So let's bring up table A2. We're going to come down here to the positive numbers, and we want 1.30. There's 1.30, 0.9032. And then to get the purple area back here, we're applying the rule of complements. 1 minus 0.9032. That's going to give me 0.0968. So the probability that a randomly sampled value is greater than 53 is 0.0968. Example 6. A normal population has a mean mu equal to 7 and a standard deviation sigma equal to 5. Find the proportion of the population that is between -2 and 10. So what we're going to have here is we're going to have two z-scores. One of them is going to be for the data point -2, and the other one's going to be for the data point +10. And what I'm going to do here, just to differentiate between the two, I'm going to say that the 2 is going to be x1, and then 10 is going to be x2, because we've got two different data points here. So for my first z-score, which I'm going to call z1, I'm going to use my x1. We're going to take -2 and subtract the mean of 7 and divide that by 5. -2 minus 7, this is -9, divided by 5. And when I divide 5 into -9, I'm going to get negative, let's see, 1.8. Now we're going to find the z-score for 10. So we're finding our second z-score. We're going to take our second data point, which was 10, subtract the mean of 7, and divide by the standard deviation of 5. 10 minus 7 is 3. 3 divided by 5 is 0.6. All right, let's graph both of these. -1.8 is going to fall down here between -1 and -2, and it's probably going to be a little bit closer to -2. All right, and I'll draw my little vertical line up to the graph here. 0.6 is going to fall over here between 0 and 1, a little bit further than halfway. And I'll draw my vertical line in right here to the curve. And so the problem says we're looking for the proportion between, so that means we're looking for all of this area in here. Well, remember, to find the area in between two z-scores, I'm going to have to subtract their areas. I'm going to find the z-score for 0.6, which is going to give me the area from here all the way back. And I'm also going to find the z-score for -1.8, which is going to give me the area for this little white part right here. And if I subtract those two, it should leave me with just the purple area right here. All right, so let's bring up table A2, and we'll start with 0.6, since I'm already over here in the positives. 0.6 is right here. The area 0.7257. And now I'm going to figure out the area for -1.8 as a z-score. All right, let's go up here to the negatives. Here's -1.8. -1.80 is right here. 0.359. So our pink area here, 0.7257 minus 0.0359 will give us a grand total of 0.6898. And there is the proportion of the population that falls between -2 and +10. Example 7. A population has a mean mu 6.9 and a standard deviation sigma equals 2.6. Find the value that has 80% of the population below it. In other words, the 80th percentile. What they're telling me here with this 80% and this 80th percentile is that the area under the curve is going to be 0.80. And since I have a mu and I have a sigma and I have an area, that means that I'm going to have to figure out what the x value was that gave me the z-score that gave me this particular situation. Okay, so we're trying to figure out what x value or what the data point was. Well, in order to get the data point, I have to know what the z-score was. So let's figure that one out. Now the area is 80%, and that 80% would be to the left. Keep in mind that from here to the middle, this is 0.5 or 50%, and 80 is more than that. So the 80th percentile is going to be somewhere over here on the right, and I'm just going to estimate it to be about right here. We are looking for that z-score, and then we're going to turn that z-score back into the data point using the z-score formula. Okay, so here's the area, because this is below it. We're going to pull up table A2, and we're going to find the z-score that's as close as it can be to an area of 0.8 or 0.8000. And we're going to be in the positive z-scores because this one's going to be over here to the right of 0. So let's pull up table A2. And I am in the negative z-scores, so let me get down here to the positive z-scores. And we want to be at 0.8, or as close to it as we can be. So here's 0.78, there's 0.81, 0.82, 0.79, 0.7995, 0.8023. Okay. 0.8 minus 0.7995 is going to give me 0.005. And 0.8023 minus 0.8 is going to give me 0.0023. So it looks like our z-score is going to be closer to the 0.7995. And so that z-score is going to be 0.84. Now your book gives you another formula to remember to try and turn this back into its data point, but I'm just going to use the z-score formula, and I'm just going to write it up here so we remember what it is. We've got x minus mu divided by sigma. I'm trying to figure out what this number is right here. I've got this one, I just found it. I was given this one, I was given this one, so I'm just going to solve this problem for x. Alright, my z-score, 0.84. X is what we're looking for. Mu I was given to be 6.9, and then sigma I was given to be 2.6. This problem is actually a proportion, and so I can cross multiply to solve it, and we'll have 1 times x minus 6.9, and that's going to be equal to 0.84 times 2.6. If we distribute the 1 inside, we'll have x minus 6.9. And on the other side, 8.84 times 2.6 is 2.184. All right, and to solve for x, we'll add this 6.9 to both sides. And we know those will cancel. So my data point is 9.084. Example 8. A population has mean mu equal to 53 and a standard deviation sigma equal to 34. Find a value that has 35% of the population above it. All right, once again, this 35%, they're telling me that the area under the curve, I want to use 0.35. We're going to need to figure out what our z-score is because we need to know what that is in order to find out what the data point was, because this is what it's asking me to do, find the data point that goes in my data set. All right, let's figure out where the z-score belongs. The area is 0.35 and it has to be above it. Above means to the right. Okay. Keep in mind, we've got 50% of the data going this direction. We have 50% coming this direction too, and we have 0.35 above it. We're not quite going to make it all the way back here to this 50%. So the area to the right, I'm going to estimate it to be somewhere in here. This is the z-score that I'm looking for. And this is the area that they have given to me. And they've given it to me to be 0.35. I'm going to use table A2 to try and figure out what that z-score is. But table 2 only gives me z-scores in areas when I know or want the area to the left of the z-score. I have the area to the right. And so over here, I'm going to have to use the rule of complements because this is the area I'm going to be looking for over in table A2. So the whole area under the curve is 1. My purple area there is 0.35, and if we subtract those, this is going to give me the area that's not shaded, and that's 0.65. All right, we're going to pull up table A2. We're looking for a positive z-score, and the area to the right is 0.65, or really, really close to it. All right, here are my positive z-scores. And I'm looking up here, we got 0.6554, so we're close. 0.6406, 0.6480, 0.6517. My z-score should fall in between these two right here. Let's see which one I want. 0.65 minus 0.648, that's 0.002. 0.6517 minus 0.65 is 0.0017. So our z-score is slightly closer to this one right here. So let's find out what our z-score is going to be. It's going to be 0.39. So I misguessed that one too. It should actually be over here in between 0 and 1. Instead of where I put it. Let's get that out of there. There we go. All right, this time I'm going to use the formula that the book gave to you, and I'm going to write it up here at the top just to remind us of what it is. And the formula is x is equal to mu plus the z-score times the standard deviation. Now, this is just the z-score formula. It's just somebody finagled it and moved it around somewhat, so instead of being equal to z, it's now equal to x. And the reason for having this formula is so that if you know all these numbers over here on the right, you can just put it all in your calculator at one time and get your answer a lot quicker than if you had an equation to solve where we were trying to solve for x in the other one. You know, we had to isolate it by doing the multiplication and then adding something to the other side of the equation. All right, so this is going to get me to my data point a lot quicker. All right, my data point is going to be equal to the mean that I was given, 53, plus the z-score we just now found, which we said was 0.39, times the standard deviation we were given, which was 34. We put all that into our handy-dandy calculator, and it gives me 66.26. So the data point that has 35% of the population above it would be 66.26.